is my project, Kafka order system. So I have created two Spring Boot projects for consumer, one for producer, and inside here I have my Avro Schema. So it has an order ID, product name and price, and this is the sample environment variables I used. So I have used a Confluent Cloud Kafka Cluster, so, and Schema Registry also from the Confluent Cloud. So I have generated two API keys, one for cluster and one for the Schema Registry, and I've set the settings here in the real environment variable file, and I have used Docker Compose to up and run in my system, and I have one for the consumer and producer. So this is my Confluent Cloud dashboard. I have one cluster. So I have two topics, one for orders. Producer will produce to this queue, and as you can see there are earlier messages. So it is using this Avro data contract, this schema, and in the topic the other one is DLQ. So basically when consumer processing the message, and if the price is more than $250, we conclude that this message is permanently error, so we push that into the DLQ. So when producer produces an order to the Kafka cluster, consumer consumes it, and when processing, if the order price is more than $250, we consider that is invalid. In that case we push it to the DLQ. So this is the DLQ, and it is also within that Avro contract, and you can see the messages, and I have set cluster settings for as 3 partitions for each topic, and it's elastically increase and decrease its compute. It has a data retention time of 1 week. So now let's run the application. I will stop the compose. So it is created, and it is up and running, and here I have created a front end. So the front end is in the consumer. It is in the Spring Boot project. Here I have kept the static files for this. Now if I turn on localhost 8081, it will go to the dashboard. So this live means it is connected to the WebSocket. This is up and running from, as I said before, from the consumer's application. So it maintains a WebSocket to keep the connection alive whenever it order is arrived and processed. After processing, it will right up show up in this consumer feed, and it also has the ability to contact with any producer API endpoint. Now it's running on 8080 producer endpoint, so we are calling there, and I can randomize my order. And if I do a normal order with like below $250, let's publish this. It is publishing. it's published. So you can see in the consumer feed it has received. Now if you go to the Confluent Cloud, if you go to the order messages, we can see the ergonomic chair is there. And it is also keeping the count, so only one product now. If I randomize to this and publish it, it will keep the running count 135. If I do 51 plus 189 divided by 2, so it is correct. And let's try error order. So in this system we don't allow for orders above $250. If you publish this, it will publish to the queue, but then when consuming at the end of the consumer side, it will detect this order is wrong and it will publish it to the DL queue as failed for later analyzing purposes. So if I go to the DL queue, it's in the DL queue, the message is exceeded its fatal threshold. So let's check the Kafka cluster if it is actually in the order queue. We have to understand that this also is in the main queue because it only pushed to the dead letter queue after consuming. So when it first produces, the error one is also there, but we processed it correctly in the consumer side. So if you check here, order DLQ, it will be published after processing in the consumer side. So if you check the DLQ, you can see this noise cancelling headphones with 327 is in the DLQ. You can see that ergonomic chair is not here because it's a successful order. And if we do another correct order, and you can see that the count is 3 but the process count is 2 because this one is error. It doesn't take the average of this one, it only adds up the correct orders. You can see its process count is 3, and you can make sure this is the producer consumer. So let's check the logs also for another random order. Count is 4, and average is 107. You can see the order is drone pro X is processed, and this exact order is sent here. As you can see, the Kafka cluster is in the cloud. So if I turn off the data connection, there is no way that the producer can communicate with the cluster and the consumer can't receive any messages anymore. Now let's try our retry logic, and now the internet connection is off. So if I create a random order and if I publish the order, can see there's error in the logs also. It is keep retrying. Now if I turn on the network connection, so it's on. You can see consumer connecting. Okay, it sent the order and it has received. So what is published, and you can see this noise cancellation headphones, it's received. And if you check the cluster, the order has successfully received. Temporary failures like network connection or something wrong with the producer, and producer will keep trying to push to the Kafka cluster. So we have managed the system to work despite the errors, but if in any case the order was incorrect from the producer side, consumer will analyze it and declare this is error, and so it will push it to the DL queue for later analysis. So that is the application, and it keeps track of the process running count and the process average. As I said before, to keep this count live, we connect to the backend via the WebSockets, and we used Avro Schema, and we created a front end, and also we used enterprise grade Kafka cluster using Confluent Cloud. Thank you.